hello everybody. Thanks again to Austmine to let us the opportunity to present these challenges. So I will start with a quick presentation of our process, because I think it's a good start to understand the two topics that we will discuss after that. So as said in the introduction, we process laterite and saprolite ore in our plant. So we feed a mix of these two kind of ore to the plant as a slurry. We thicken the slurry and we feed this slurry to our HPAL process. So we have extreme condition in our HPAL process. We are at 260 degrees in the HPAL, so in the autoclave, so very extreme conditions. We will do the leaching, adding sulfuric acid in the autoclave to dissolve the nickel and cobalt and all the other impurities. After that, we have a step of separation of the liquid and the residue of the autoclave, the solid residue of the autoclave. And then we feed the liquid solution, the PLS, the pregnant solution, to a step of neutralization. We neutralize with limestone in the first step and then with lime. And after that, we arrive to the last part of the process where we will precipitate our final product as MHP using magnesia in the process. After that, we have a lot of solid residue coming from this process, mainly residue from the leaching. So we have a residue of hematite and alunite, and it's a mix with the gypsum created during the neutralization process. And all this solid is sent to a pond that you can see on the first picture. This slide will settle in this big pond, and after that we pump back the liquid on the plant to treat it and to pump it to the ocean. It's our liquid effluent that we pump to the ocean after the treatment on the plant. So that allow me to introduce the first topic, the first challenge that we want to discuss here. So the first one is that as we want to treat this liquid effluent, we use lime to do the neutralization and the precipitation of the last elements that we have in the solution before being able to pump it to the ocean. So the last element are the manganese. The main one is the manganese, and we need to target concentration under 1 ppm of manganese. So to do that, we need to use a lot of lime to precipitate the manganese. And doing that, we saturate a lot our effluent with calcium. After that, the effluent is pumped to the ocean in a big pipe. So we have a part of this pipe which is onshore, which is 5 kilometers onshore. And after that, the pipe go in the sea, and we have 20 kilometers of pipe under the sea to go to the effluent outfall, where it's released in the ocean. The issue is that with this saturation of calcium, we have a desaturation finally of the calcium in the effluent pipe, and it desaturates, precipitating as gypsum in the effluent, in the pipe. So finally, a part of this gypsum will go through the pipe and goes to the outfall, so it's not a problem, but part of this gypsum will also precipitate on the wall of the pipe. We precipitate on the pipe. It's a small part of the gypsum, but it can create a thin layer around until 3 millimeters of thickness of gypsum. And because of that, we have a loss of pressure in the pipe, and it reduces a lot the flow that we can pump in this pipe. We really need the maximum flow of pumping in this pipe to be allowed to empty and to evacuate all the liquid effluents that we have on the plant. That's why we want to present this challenge, it's because we are looking for a solution to tackle this issue. So it can be something like avoiding the precipitation of the gypsum on the pipe, or something like a method to descale finally the pipe when it's already scaled, when we already have the thickness of gypsum. Maybe we can go to the next slide, please. Perfect. So here you have a picture of the pipe on the right. So that's the N 700 pipes. And here you can see just a little bit of scaling in the pipe. So that's just an example of what we have. It's a very thin thickness, but it's enough to be a problem and to reduce the flow a lot. So as I said, two kind of solution are expected. So the first one is avoiding the precipitation, avoiding the precipitation on the pipe. And the second one is a method to descale. So it can be a mechanical method or other. But we have a big constraint at this point, because it's a very delicate topic. As we send this effluent to the ocean, we really need to be very careful on what we do in this effluent, and what if we want, for example, to add some product to avoid precipitation or to remove the scale. We really need to be sure that this product is okay with the release in the environment. That's why that will be the most difficult part, I think, of this challenge. Is just to be sure that we keep the right to send this effluent to the ocean. So, as I said about the solution, we really need for sure to keep the safety around this operation. So it's normal. We have to keep the effluent quality. As I said, we need to stay in the limits that we currently have in terms of the different elements that we have in the solution. And if we add new element to the effluent, we really need to be sure that it's okay to release this kind of thing in the ocean. And if it's a mechanical thing, there will be, I guess, a cost. And as we know, it's the current world situation is complicated and all the costs are very high. So we need to be careful about the cost also. So I